All right, so our next speaker is Joseph Salazar, who will present us Venus Cloud Simulator Test Facility. Joseph, please.
Hello, my name is Joseph Salazar, and I'm from JPL. And what a great introduction to my talk from Kevin, talking about the macrophysics of clouds. Here, I'm going to introduce a Venus Cloud Simulator test facility to test equipment that could be flown to Venus. So I want to introduce my team that worked on this project with me, including Mike Pauken, who's also the PI on the upcoming chamber that Kevin just introduced, Rick Flagan, who's an aerosol expert, me, who's a postdoc who works to design the facility. Then we have undergrad Josh Hessel, who helps build and assist in parts of the facility. Azad, which will helps us determine sulfuric acid and materials resistant to sulfuric acid, and Lynn and James as kind of oversight and project managers. So here's going to be our target for our Venus clouds. We're going to simplify everything that Kevin just said to just sulfuric acid, in order to test the robustness of equipment in a Venus atmosphere. And so over to the right or to the left, we have the particle distribution that we're aiming for in our Venus cloud chamber. And then to the right, we have the mass density and concentration that we'll be looking at hitting. We're going to be looking at simulating clouds from about 50 kilometers to a little bit above 60 kilometers in our cloud chamber. So over here is a picture, as an image of our first iteration of the cloud chamber. We have a robotic arm inside that we'll be using for testing simulated Venus clouds. And kind of the overall objective is to test equipment for its reliability and performances for a new Frontiers mission. And so we're going to be corrosion resistant testing of materials, and we're also going to provide a calibrated aerosol source for any mass specs or nephelometers that may be flying to Venus. Here's the flow through diagram of our Venus cloud chamber. And I'm going to walk through it right here. So in the middle, we have the atomizer gas flow, which is the part of the chamber that's going to be making these sulfuric acid aerosols. So basically what we have is a gas supply going through a pressure regulator and a mass flow controller into an aerosol generator, where it's pulling up liquid sulfuric acid into this aerosol generator to generate sulfuric acid aerosols. These sulfuric acid aerosols then go through an X-ray source to neutralize any charge that has been built on them through the generation process. From there, they get mixed in a mixing section with a dilution gas flow that's been heated to 60 degrees C, and then they enter the cloud chamber. Before they enter the cloud chamber, we're going to look at the distribution with a particle optical spectrometer just to make sure that we're getting the constant distribution of aerosols as we're testing equipment for corrosion. So this new facility will be able to generate sulfuric acid aerosols and either gaseous nitrogen or CO2 carrier gas. It's going to be flowing about 60 liters per minute for a continuous exchange of gas and aerosols to prevent any particle setting and to take advantage of kind of a renewing aerosol source. And we're going to keep the temperature to 60 degrees to simulate the Venus atmosphere. So our first task was kind of, how do we get a particles distributed in a square box? We went through a number of fluid simulations to kind of get this kind of understand and get a uniform distribution, or as uniform as we could, distribution of gas and aerosols in a square box. And what we decided on is a nozzle that will go in the inlet of the box. It's going to be attached to the 2-inch out inlet, or 2-inch inlet into the box. It's going to have 6 holes at a 45-degree angle. And when we tested this in the dynamics, it showed that this had the lowest number of particles being lost in the distributor nozzle and the most number of particles exiting the chamber. So minimizing wall loss as much as we can, which is a huge problem for chambers. So here's kind of how we tested the chamber to make sure that our simulation is matched with the reality. Right here, we have a robotic arm that we used attached to a black tube, which drew air into a particle counting device. And here I have a quick video. This is a sped up video of the robotic arm sampling different areas in the chamber. As you can see, we could see completely through the chamber. This is one of the lower aerosol counts. And we'll kind of walk through the data analysis here in just a second of what we saw in the chamber. So that video was from this original set right here. And kind of orientate you to the graph right here. We have the particle density over here on this axis and then the particle diameter. Each of these black lines represent a different location in the box. These red lines right here are kind of our targets of aerosols that we're trying to hit. We're trying to get somewhere between these two or around these two lines. And so we had 3 different tests we tried. Our first configuration, which you saw in an earlier photo, has the aerosols coming in and making a 90-degree bend, and then another 90-degree bend through the particle into the box. And as you can see in this kind of image right here, we're getting a lot lower particle count than what we want to have to simulate the Venus environment. So from there, we switched up the box entirely, eliminated all the 90-degree bends and the distributor to get the maximum amount of particles we could in the box. In which we started reaching these the targeted particles. After that, we put the distributor back on to see if we could tighten up the particle distribution around the box and kind of make the particles more uniform. Because if you see, there's a spread about 2 orders of magnitude, or 4 orders of magnitude, sorry, right here. And then we were able to tighten up the particle distribution to roughly 2-ish orders of magnitude. Because mass is also an important indicator of corrosion and how much things are corroding, we wanted to make sure we also hit the targeted mass that those Venus cloud layers have. And so right here, we have a 3-dimensional plot of the box and different areas in the box with the mass concentration right here. These red dots in the middle and some of the outlining are the targeted mass concentrations that we're attempting to hit. And then the darker dots are the higher mass concentrations. And as you see towards the edge, bottom and the upper edges, we do get lower mass concentrations. So when we start testing equipment, we'll want to put the equipment right in this middle section. And then here's the mass concentration by particle size, showing that we have the highest mass concentration around 3.5 microns. I also forgot to mention earlier, for these tests, we're using simulated aerosol particles. We're using ethylene glycol because it matches the viscosity of sulfuric acid. So we don't have to worry about our equipment being sensitive to sulfuric acid for these initial tests, and we can get a robust data set. And so what we've done here is we were able to build a chamber to simulate the 50 kilometers to around 60 kilometers of clouds in Venus, and get a similar matching aerosol distribution with ethylene glycol. Moving forward next, we're going to be working on switching all the equipment to sulfuric acid resistant materials, and we'll be working with sulfuric acid. Well, we'll be testing equipment and coupons to address how corrosive of an environment we've created in the simulated cloud environment. And that's all. Thank you.